First thing that we would start with is, what do you remember about similar triangles? Brianna? Good. Very nice. So the angles are equal, and then the sides are multiples of each other. We would call that like proportional. There's a proportionality between side lengths as well. Ethan, what were you going to say? Same idea? Very good. So that is a great summary. Now, what do you remember about how to solve these questions? What are we even solving for? We're finding the values of x and y. And if you are good at picturing stuff, you might be able to just kind of dive in. But if you're not, we have a series of steps that we can go through that can help us make sure we get everything in the right order and everything aligned properly. This one's a little bit different. I don't think we've done a question quite like this one. So let's give it a try. What do I do to start one of these kinds of questions? Summer, what do you think?
Isn't it like the A, E, B?
Mm-hmm. Yep.
The angles that are similar, they're like the dots.
Yes, very good. Yep, very good. So, but this one doesn't have dots. But in other words, we're going to find which angles are equal to each other. How do we do that in a diagram where we're not given the dots? So, for example, you might have been given something like this. Dot and a dot. But we're not. So how do we figure out, can anybody tell me two angles in this picture that are equal, Ethan? B and E, how do you know?
It's the symbol on the line on the bottom. Yeah.
Okay, good. What else can we add on to that? The other thing you might, before we keep answering that, the other thing you might think is like, how do we even know, like what are even the triangles that we're talking about? Because when we did this before, we had two separate triangles. One was drawn over here, and the other one was maybe drawn over like that, right? And they were labeled, and they had those dots, that kind of thing. This one doesn't have them. So what are the two triangles? Well, one of them is ABC, okay? But the other one is, let's say, EDC, right? And they're connected. That's going to be important. Brianna, what were you going to say?
I want to say that A and B are equal just because the side lengths are 10 and 20, and they should see together.
Interesting. Okay, good. So we've got a bit of disparity there because somebody said B and E are equal and somebody else said A and E are equal. How do we know? Now, if you look at it, B and E look more similar, but you can't just go by that. So there is a way to tell without any like discussion or without to be absolutely certain which angles are equal. It's not something we've done in this class, but we talk about it in grade 9. And it had to do with the arrows on the lines that somebody mentioned. What do those arrows tell us? Thomas? Very nice. So that's really important, though, that those lines, the line between AB and the line between DE, are parallel. What do you think? Kenzie, any ideas? What if I do this? A Z pattern. What is a Z pattern? Yeah? Yeah, the two angles on the insides of the Z are equal to each other. If the top up here and the bottom down here are parallel, and there's a straight line connecting those two parallel lines, the Z pattern says that the angles inside are equal. So that's how I can know for sure that this one equals this one. So I'm going to write that down. B equals E. What else can I tell? What are the other two patterns? They have different letters associated with them. C and F, but We will see the F. Yeah, we will see the F, so that'll be useful. The C won't really be as useful. I mean, it's there, but it's not necessary. But the Z pattern in a question like this is good. Okay. What else can I do? Ethan? A equals D. How do you know? So there. Very nice. Good. A equals D. Okay. And C equals C. That's a bit of a strange one, but isn't that true? This is the same, not because it's actually not exactly the same angle, because one's on the top and one's on the bottom, but they're both at the same point that we call C. How do I know those are equal? There's a theorem in grade 9 that you learn as well. They're opposite angles. So opposite angles are equal. That's something else that you learn about in geometry, right? So bringing back a little bit of that geometry from grade 9 to figure out which angles are equal. Once you've done a question like this once, though, with the two triangles that are like tip to tip, the rest are all kind of the same. But you do have to get the right angles in the right spots, obviously. Okay, what's the next part of this process? I'm going to start with triangle BAC, similar to triangle EDC. Right? So I just did these both in a row because you don't just go alphabetically. That won't always work. And I use that to set up our proportionality statement. If you want to watch, you can watch. So I start with BA and ED, the first two of each of the triangles. BA, and people got this, when we did this on the test, absolutely this is where a lot of people made the mistake. They got the wrong numbers in the wrong spots. Is equal to, okay, and so now I'm going to do the next two, AC and ED. So AC and ED. And then the last combination, which is like the first and the last in each. CB over CE. And little things that you might notice, or you should notice, you want to pay attention to, is all the ABC. The one triangle is all on top, and the other triangle is all on the bottom. That one should say DC. Right? Yeah. AC over DC. None of them are repeated. I had one repeated. That's how I knew it was wrong. ED twice, that's wrong. So they all have to be different. But ABC is all on top, and the EDC is all on bottom. What's the last step? Noah, what do you think? Plug in the numbers. Awesome. So let's do that. AB or BA is 15. And ED is X. AC is 10. DC is Y. Some people got the proportionality statement written properly and then subbed in wrong. CB is 13. And CE is 20. And again, you might want to just take a look. One of these has X, but it also has a number. One of these has Y, but it also has a number. And then one of them has two numbers. You have to have that, right? You can't, one of them has to have two numbers. That's how I can solve this. If that wasn't the case, then you wouldn't be able to solve it, right? So now what do I do to do the rest, Summer? Yep. 15 over X equals 13 over 20. Yep. Yep. Okay, good. And so what Summer's saying is you can't solve with all three in there. So we're breaking it up into like two separate questions, right? So I take the one that has both numbers, and then one of them, I just pick one, and I set it up here. And then I'm going to take the other one, I'm going to take one that has the same one that has both numbers again, and the other one, and I'll set that up over here. So I'll do that 10 over y equals 13 over 20. If there's two variables to solve, you got to set it up into two separate questions like that. Ethan.
Isn't it CE over CE?
Why would it be that?
Sorry.
Why do you think? Okay, that's okay. We're good? Good. So now the last step is how do you solve a proportion? And Summer was already telling us there's different ways of doing it, but one of the ways was if you have x on the bottom, flip. But when you flip, so I want x on top, but when I flip one side, I have to flip the other as well. Whoops, so 20 over 13. And then this is like an equation with fractions. It is an equation with fractions. Not like one, it is, right? And some people like to do the cross-multiplying thing here, but you don't have to. It's even easier if I just multiply both sides by 15, multiply by 15, and on this side, the 15s are gone. That's why that works. And then I'm going to need my calculator for that. We're going to round this to one decimal place. I do 20 times 15 divided by 13. And I got 23.1 meters. Okay, try that one. Try the next one. See if you can solve it. I got 15.4. Any questions about that? Okay, so we're going to look at a couple of different kinds of questions again. So this one's a little bit different. See if you can draw it and then think about angles. Like start thinking about the angles that are equal. So try that part. So the last diagram had two triangles that were touching each other. This one's a little bit different. How would you describe these two triangles? Yeah, one of those triangles is inside the other triangle. Sometimes you hear these called nested triangles. They're like nested shapes or nested figures. One's inside the other. So what are the two triangles? Kenzie, what are the two triangles? Not even which ones are equal, just what are they? Yeah, ADE is one of them. So that was this one. ADE. Good. What's the other one? That's not a triangle. That's a quadrilateral. Okay, fair enough. ABC. ABC. One's inside the other. But kind of interesting that the other one is like a trapezoid, so it's possible that you could do some geometry with that, but we're not going to. We're just going to use similar triangles. And I got two lines that are parallel again. That's going to be important. So what's our first step? Thomas? Yeah, figure out the similarity of the triangles. And so to do that, let's look at the angles. So who could tell me two angles that are equal? Remember the triangles, you could write this off the side, are A, D, E, and A, B, C. Those are my two triangles. Tell me one pair of angles that are equal. A equals A. It's a good one. Again, that's a little bit different. The last one, the reason why C equals C was because of opposite angles. This one, A equals A, because it's the same angle. It's exactly the same angle. B and D, how do you know? The C pattern and also the F pattern. So both of those, that's true. Take a look right here. And the C pattern is a little bit different, but it does work. But the F pattern tells me that the two side lengths inside and the bottoms of the F, this is like an upside down F, are equal, right? So those two are equal. And the F pattern tells me that. Very good. Okay, so D equals B. And once I have two, whatever's left over is equal, but E equals C because of the F pattern again. Okay. The C pattern, by the way, tells me something about the two inside angles, but they're not equal. They add up to 180, right? Just, we don't need to use that in this case. Once we get the angles that are equal, we're done. All right, so then we can write our similarity statement. Triangle ADE similar to triangle ABC. Okay, I want you to try to write the proportionality statement. I'll start AD over. Fill in those other blanks. Nope. Don't have to put, like on top, you mean? Doesn't have to be either way. It'll work whether one's on top or the other's on top. Okay, hopefully you got this. And now we have to fill in the values. So somebody tell me some value. Anything. Jake? Yeah. Yep. AD is 34. Awesome. 34. Okay. Somebody else tell me another one. I'll come back to you. Ethan? AB isn't just Y because it goes all the way. So that's the hard one. What do you think? Okay. Which one's 65? You think it's also 65? What do I know for sure about the 65? It's a C. Can I do that one? Or CA? Think it's going to be the same? Let's find out.
I don't wanna argue that it's 65 because AE is 35, let's say that 35 is, like just looking at it, that would be 65, so.
Okay, interesting. Okay, so here's the thing. It may work out to be 65, but if we say that, that's an assumption. There's nothing in the diagram that specifically tells us it is 65. If it works out that way, great. These are different, just by a little bit, which leads me to wonder if the other part's probably a bit different as well, right? Like they're not identical. Now, it might round to 65 because they're so close, but still, okay? But what do we know for sure is, I'm talking about AB here, so I'm filling in this gap. From A to B is y plus 34. If I add those together, this is a new idea, but if I add those together, yes, that works. This is a tricky idea, but that is an expression for the length of that side. Just like when I fill in DE, where's DE? I'm going to put an X, because X is the length of that side. It's an unknown. Unknowns don't always have to be just a variable. It could be an expression like y plus 34. Okay, interesting idea. BC is the 55. Those ones kind of obviously go together. And then AE is the last one, and that's the 35. Let me get rid of some of this junk. Oops. Okay, so think about that. Y was this distance. 34 is this distance. So the whole distance here is y plus 34. So now we're going to do the same thing. I'm going to take this down here, and I'm going to set up two proportions. One of them is 34 over y plus 34 equals 35 over 65. And the other one is x over 55 equals 35 over 65. The one on the right is pretty easy. How am I going to solve the one on the left? Brianna? Flip? Okay, let's do that. And who thinks they know how to solve? Like, go ahead if you think you can solve the rest of that. That's what we were working on a couple of weeks ago, so it should look at least somewhat familiar. How do we solve equations with fractions? No matter what changes about them, what always works? So give it a try. So I got y plus 34 equals 63.1. What's my last step? Liam, what do you think? Have any ideas? That's an interesting idea. What else could I do here? Ethan, what were you thinking? Okay, interesting. Riley? Which one of the, so subtract 34, which gets rid of it. Whatever I do to one side, I do the same to the other. Okay, and then I end up with y equals 29.1. And then my x, I could solve that easily, right? By multiplying by 55 on both sides. You can finish that one, but that one's the same, straightforward. Any questions about that? We're going to do one more that's a little bit different again. Questions about that? So this is like what you are going to have to be able to do. So if you don't understand it, if you don't think you can do it, then now is a good time to ask. So in fact, this looks like very much the same kind of triangle. So let's get through the first part of it. A equals A. B equals D. C equals E. Like, I think it is basically the same triangle. Numbers are different, but it's the same sort of setup. So triangle ABC is similar to triangle ADE. Set up my proportionality statement. AB over AD is equal to BC over DE is equal to CA over EA. So what's different about this question is a couple of things. I have fewer values. I'm only looking for x. There's no y. There's no values on this side. What do we do when there's no values? Who remembers? Any ideas? Just leave them blank. AB over AD, just leave it like that. It's just gonna, you don't do anything with those. Like, you're only finding x. That's all you have to do. So we just don't worry about it. In fact, you wouldn't even have to write it if you don't want to in the next step. Okay, so try to sub in for the last 4. There's 4 open spots there. Sub in as much as you can. Okay, who can tell me something in here? Sam, you got any ideas? Even if you just pick an easy one. Okay, so hold on. BC, nice, is 25, and DE is 15. Awesome. Okay, great. So there's our one that's got the 2 values. Very good. And then what? So do you have the rest? Okay, so AC or CA is 17 plus X, and EA is X. Very nice. So this one's a little bit different again, because I've got X and X plus 1. If we go back up, it was Y plus 34 over 34. So this one's a little bit different because it's X plus 17 over X. Okay, so I end up with this, 25 over 15 equals X plus 17 over X. How do I solve? So this is new for us. How do I solve an equation like this? How do we always solve equations with fractions? Yes, you do, very good. But it's not necessarily obvious how you do that. So let's go back to that idea of just in general, how do you solve equations with fractions? Yeah, you get rid of the denominator. And how do I do that? By multiplying. What do I multiply by? All of the denominators. Watch what this is going to look like. One of my denominators is 15. One of my denominators is x times 25 over 15. Doesn't this look familiar? 15 times x plus 17 over x. And then again, you want to watch carefully here. These guys are gone. And these x's are gone. And I have no fractions left. So x times 25, that's 25x. And this works out to 15 times x plus 17. Do you remember that? That's from like a week ago or whatever. So 25x equals 15 times x, 15 times 17. So 15x plus 15 times 17, is that 255? Awesome. 255. Subtract 15x from both sides. I get 10x equals 255. What do I do here? Just divide by 10. We've done this hundreds of times probably in this course. 25.5 centimeters. Any questions? Okay, take a look at the practice we're going to do. The first page has 4 questions. Try the first one, A and B. C and D are very similar, so you don't have to do both of those. So try A and B, and then on the next page, there's a couple that are of those sort of trickier types. So you can move on and try those 2 as well. They are in the classroom. I'll leave these 2 up here. I think you want to draw it, and you want to mark the equal angles, or if you don't draw it, just do the this equals this, this equals this, this equals this. You could do that as well in your book. Yes? 25.5.